when you're shooting the stars, you have a choice. You can shoot star trails or you can shoot pinpoint stars. So star trails are where you leave the lens open for a long time, and because of the movement of the Earth, the stars, of course, don't move. If you aim your camera at Polaris, the North Star, the stars appear to revolve around that star. So the axis of the Earth points to Polaris, which is why they appear to rotate around it. But if we're going to talk about pinpoint stars, so if you take a picture like this, and you want pinpoint stars like we have here, we're going to talk about how you do that. And basically, your exposure time is going to be based on the focal length of the lens. So the first method I'm going to talk about, I don't recommend you use, but I want to tell you about it because you've probably heard about it. You'll probably read a lot about it. It's wrong. It's called the 500 rule. It's based on film. When we shot film, we used to use the 500 rule, but it doesn't apply to digital cameras, which are much higher resolution now. So it's basically you divide 500 by the effective focal length. So if you're shooting a 14 millimeter lens, you divide 500 by 14 and you get 35 seconds. So based on the 500 rule, with a 14 millimeter lens, 35 seconds is the maximum exposure you could take without blurring the stars. So the stars look like pinpoints. Anything longer than that, and they start to blur, start to look like star trails. And as you can see with a 24 millimeter lens, the longest exposure is 20 seconds. However, as I said, this is based on film, doesn't work with high resolution digital cameras. So this isn't something that you're going to want to use. Longer exposures do allow for lower ISO speeds, however, in smaller apertures. So extreme wide angle lenses are best. And it's going to be best on this other method I'm going to tell you about now too. So here's an example of how fast the Earth moves. If you watch this, you're going to see the stars move. The trees aren't, but the stars are. And these two images were taken 6 seconds apart with a 105 millimeter lens. And in 6 seconds, there was that much apparent movement, but that's with 105 millimeter. Had I shot it with a wider angle, we wouldn't have seen as much movement because it still moved, but the wider angle, each star is much, much smaller and you don't see the movement as much. So the stars actually appear to move quite a bit during the night in between different exposures. So the method that does work